Greetings. Hello, everyone. My name is Alvin Robancho. This is a brief rundown of the Telecommunications Infrastructure Modernization Project for the United States Embassy in Freudenreich. The U.S. ambassador to Freudenreich noticed that the current state of the embassy's telecommunications infrastructure cannot meet the demand from U.S. citizens, abroad, and local populations seeking visas to travel to the United States. The ambassador has asked for outdated telecommunications infrastructure to be updated and for the adoption of current technologies. Next slide. Slide 2, Project Overview. This project focuses on updating the telecommunications system at the U.S. Embassy Freudenreich. The current infrastructure is outdated and unreliable, affecting daily communication and overall mission support. The upgrade centers on new structured cabling, updated racks and network hardware, and complete system testing to verify that everything performs as required. These elements form the core of the project scope found in the original scope statement and the statement of work. The project's work touches several areas inside the facility, including cable pathways, equipment rooms, and end-user network connections. Each piece is tied to the embassy's need for dependable and secure communication channels. The work breakdown structure breaks tasks into stages so the team can move from design to procurement, installation, and testing in a precise, ordered sequence. The Gantt chart then shows how these tasks fit together across the schedule, and the resource plan identifies the people and materials assigned to each activity. The critical path identifies the tasks that cannot slip without affecting the overall timeline, and the earned value approach enables sponsors to track progress against cost and schedule. Upgrading the infrastructure strengthens operational continuity and supports the embassy's broader mission environment. Next slide. Slide 3, High-Level Project Objectives. The project has a few main goals, all of which tie back to getting the embassy's telecom system to a place where it supports daily operations without constant issues. The telecom rooms are part of it. Most of them are old, crowded, and set up in ways that do not match how newer equipment is built. So one objective is to update those rooms and clean up the cable routes so the new system can fit and operate as it should. A study on ICT facilities found that fundamental layout problems can degrade network performance over time, aligning with this project's aim to address them. Another goal is to install structured cabling that complies with telecom code rules and BICSI guidance. Embassy networks rely on clean cable testing and labeling, so sticking to standards helps avoid minor problems later. Research on cabling shows that staying within those standards improves long-term reliability. There is also the upgrade of the active gear. New switches, routers, and wireless systems provide the embassy with improved security and better traffic management. Work on network modernization has shown that a mix of physical upgrades and updated hardware improves resilience and stability. Operations must keep running while all this is happening, so the project is planned in stages. The last step is passing final inspections and getting everything certified. Next slide. Slide 4, Statement of Work Summary. The statement of work outlines the project's responsibilities at the U.S. Embassy Freudenreich. The job starts with a site survey, where the spaces are reviewed, measured, and documented so the design team knows exactly what they are building around. After that, the project produces a complete telecom design package. This includes drawings, equipment layouts, cable routes, and the different submittal stages the embassy requires, all spelled out in the SOW. Once the design is approved, the work shifts toward procurement. That means ordering the materials, network hardware, racks, cabling, and tools that meet OBO, BICSI, and TIA standards. When materials arrive, the team installs and terminates the structured cabling and fiber, sets the racks, and prepares the network equipment. Studies on infrastructure installation emphasize how standards-based work reduces long-term failures and improves reliability. Testing and certification follow the installation. Every cable run must pass Tier 2 testing, and wireless coverage must meet the embassy's performance thresholds. Research on ICT quality control highlights the importance of structured verification for secure environments. The project then closes out with updated as-built diagrams, test results, material lists, and any required operator training. These items form the final deliverables, which align with typical expectations for modern telecom upgrades in mission-critical settings. Next slide. Slide 5, Scope Statement Highlights. The scope of this project centers on addressing the fundamental problem the embassy has been dealing with for years: unreliable, outdated telecom infrastructure. The intent is straightforward. The embassy needs a cable plant and equipment setup that does not fail during routine operations and supports the security requirements that the Department of State expects. The scope focuses on installing new structured cabling, replacing old racks, and installing modern switching equipment that supports current mission needs. Most of the technical direction comes from the telecom code, the DS standards, and the usual BICSI practices that guide the design of cable routes, terminations, and telecom rooms. The team must follow those standards throughout the work, even when access to spaces is limited. The embassy environment usually complicates things because people still need to work while cables are being pulled or equipment is being moved. That is the primary constraint. Another is the short access windows, especially for controlled areas. Some assumptions were built into the scope. One of them is that all spaces will be open to the team as scheduled. Another is that vendors and shipments will show up on time. These assumptions matter because delays in either one affects the entire installation sequence. Next slide. Slide 6, WBS Overview Level 1-4. The work breakdown structure defines the overall project structure and provides a clear view of how each part of the embassy upgrade is organized. The first section, Initiation, covers early work such as the site assessment and confirming what the project needs, which aligns with the planning packages in the WBS document. The following section is the design phase, where the team works through drawings, reviews, and final approval steps. This includes gathering field data and developing the design through the usual 35, 65, and 100% stages. Procurement follows the design work. This section covers selecting vendors, processing orders, and coordinating shipments, especially since embassy projects often involve customs procedures and longer delivery routes. Studies on ICT project logistics show how delays at this stage can affect the entire schedule. Installation is the most significant phase. It covers site prep, cable routing, termination, rack installation, and equipment setup. Work on structured cabling projects has shown that proper sequencing and consistent labeling help avoid rework in later stages. After installation, the project moves into testing and verification. This includes Tier 2 certification, equipment configuration, and the preparation of test reports. The final section of the WBS is closeout, which wraps up documentation, inspections, and turnover. Research on ICT closeout processes notes the importance of accurate records for long-term system stability. Next slide. Slide 7, Key Project Tasks from Gantt Chart. The Gantt chart lays out the project in the order in which the work naturally happens. It starts with the site survey and walkthrough, which is the first real task after the kickoff. That early fieldwork is shown at the beginning of the chart and ties directly into the design activities that follow. The design work depends on those measurements and photos, and the week 4 estimating file shows how the drafting and review durations were set using that information. After that, the chart moves into cable pathway preparation and procurement. Embassy projects lean heavily on delivery timing, and the Gantt chart reflects this by placing procurement in the middle section and connecting it to the installation start date. If racks, cables, or hardware arrive late, it affects several other tasks. Studies on ICT project logistics note how procurement delays can impact performance and scheduling in similar projects. Cable pulling and termination take up most of the schedule. The week 4 activity estimate document shows how these durations were based on production rates and crew capability, rather than fixed numbers. Rack installation and equipment setup follow in a similar sequence. Installation work relies heavily on proper staging, and research on structured cabling reliability supports the value of following these steps in order. Testing, certification, and system-level checks appear near the end of the Gantt chart, and the final inspection is one of the last tasks before closeout. Next slide. Slide 8, Durations and Dependencies. The durations used for this project were taken from the internal activity duration sheet, where each task was estimated using a mix of production rates, labor pacing, and the usual field conditions expected in an operating embassy building. The estimating sheet shows how long the team expected the design work, cable pulling, termination, testing, and closeout tasks to take once work started. These numbers helped shape the schedule that the rest of the project documents rely on. The dependencies are straightforward. The design work must finish before anyone starts ordering hardware, racks, or cable. The drawings drive the bill of materials, so procurement cannot realistically begin unless the design is locked in and approved. The project paperwork reflects this sequencing, which is consistent with how structured cabling and network modernization projects typically run. Procurement must also be completed before installation. It does not make sense to bring the cabling team on site if the racks, patch panels, fiber enclosures, or switching gear are still in transit. Research on ICT project logistics notes that installation delays often come from misaligned procurement timing. Installation then needs to finish before testing begins. The testing stage requires completed terminations, powered equipment, and stable pathways, which are standard across telecom infrastructure work. The sequencing logic document summarizes these relationships and explains how tasks are positioned to keep the project moving, even when workspace access can shift in an active building environment. The durations and dependencies together create a schedule that follows accepted project management practices for technical work. Next slide. Slide 9, Critical Path Summary. The critical path for this project follows the work that must be done in a straight line with no room for slipping. When the team mapped out the project documents, it became clear that 6 activities sit right on that line: site assessment, design work, procurement, installation, testing, and final closeout. These pieces carry the whole schedule, and if any one of them runs late, the finish date moves with it. That is typical for telecom upgrades in active government facilities, where the work depends on approved designs and controlled installation steps. The critical path starts with the site assessment because nothing else can begin until the field team understands the actual room conditions, cable routes, and existing equipment layouts. The design phase follows, and this part is especially sensitive. Until the drawings are reviewed and approved, the project cannot order materials or plan the installation sequence. Many engineering and technology projects exhibit a pattern in which design delays trigger a domino effect later in the schedule. Procurement sits next on the path. The team depends on vendors shipping cable, hardware, racks, and switching equipment on time. If deliveries slip, the installation team cannot start, which is why global supply chain timing often becomes a major scheduling factor in ICT projects. Once materials are on site, installation becomes the longest stretch. Structured cabling work must follow a specific order, and these tasks often constitute the critical path in network-related projects. Testing and closeout finish the path. Certification cannot proceed until everything is installed, and final documentation cannot begin until testing is complete. The project files show that these tasks anchor the end of the schedule and confirm why they carry zero float. Next slide. Slide 10, Resource Plan Summary. The resource plan for this project is straightforward. It revolves around the people who make the work happen and the gear they need on hand. The project manager basically keeps everything moving, watches the schedule, and steps in when something starts to drift. The telecom engineers carry the technical load. They put the design together, provide clarifications when questions arise, and return at the end to check the system and run the tests. That pattern is typical in telecom upgrade projects, where engineering involvement tends to stabilize outcomes. Most of the hands-on work falls to the technicians. They handle cable pulls, terminations, mounting racks, and tying in the switching gear. Their tasks usually shape how quickly the installation proceeds, as noted in structured cabling studies examining labor pacing and installation flow. A procurement officer fills the final significant role by tracking orders, managing vendors, and ensuring materials arrive when needed. Procurement timing can change the whole pace of a job, so that position carries weight in keeping installation from stalling. On the material side, the list is what you would expect for a modernization effort: Cat6a and fiber runs, racks, patch panels, switches, and wireless units. The test gear matters too, because nothing can close out until the copper and fiber links pass certification. The resource plan lays all of this out clearly in the project file. Next slide. Slide 11, EVM Measurement Plan Overview. For this project, the EVM plan is meant to give the team a simple way to see if the work is staying on pace and if spending is lining up with what was planned. The baseline schedule provides the planned value, and each completed work package is added to the earned value after it has been reviewed and accepted. The actual cost comes straight from the hours posted by the crew and the material charges tied to each stage of the job. The team uses a few natural checkpoints, so the numbers mean something. The first one is design approval, because it shows the project is ready to move from planning into field work. The next step is completing procurement, which signals that the materials and equipment have cleared the pipeline. The halfway point of installation is another milestone, as it shows whether the crew is keeping pace with the original schedule. The last major checkpoint is the end of testing, right before the project enters closeout. At each point, the PM checks the SCPI. If either value starts drifting, it signals that the tasks driving the slip should be reviewed. Most corrections involve shifting labor around, clearing procurement bottlenecks, or adjusting sequences so the crew is not stuck waiting for parts or access. It keeps reporting honestly and provides sponsors with updates based on real progress rather than guesswork. Next slide. Slide 12, Schedule Performance EVM Example. When evaluating schedule health, the project team relies on the Schedule Performance Index because it provides a quick reality check on whether the work is keeping pace with the plan. An SPI below 1 means the earned value has not caught up to the planned value, so tasks are slipping. An SPI above 1 shows the team is getting work done faster than planned, though in infrastructure work, that can sometimes reflect straightforward early tasks rather than true long-term momentum. The embassy environment adds pressure because access windows, escort requirements, and security checks all limit the hours that crews can work. When SPI starts dipping, it usually means one of those constraints is hitting harder than expected, or a dependency took longer than planned. The team watches this number closely around the significant milestones, such as design approval, equipment arrival, and the midpoint of installation. Those points are tied directly to critical path activities, so a drop in SPI there is a warning sign that the path could shift or extend. Using EVM keeps the conversation factual instead of subjective. Rather than saying, "it feels slow," the SPI gives a quantifiable signal to adjust sequencing, add labor, or revise the forecast before the delay spreads. It also helps sponsors understand where the project stands without having to guess. Next slide. Slide 13. Cost Performance EVM Example. For cost tracking, the team relies on the CPI because it provides a clear answer on whether the money spent matches the amount of completed work. When CPI falls below 1, it means the project is paying out more than the value that has been earned. In a telecom upgrade like this, it usually shows up when the crew is ready to work, but the materials or equipment are not on site. Every hour the technicians wait is an hour charged, even though no progress is made. Procurement delays are often the most significant cause of that kind of overrun, especially when shipments slip or vendors push back delivery dates. Installation delays add their own cost pressure. If routing cables or mounting equipment slows down, it can push the rest of the work into tighter windows, and the PM may need to add more labor or extra shifts to keep the schedule from drifting further. Those moves drive up the actual cost, even when the scope is not changed. The CPI helps the sponsor see this pattern clearly. Instead of guessing where the extra cost is coming from, the EVM report shows whether the issue is early procurement, slow installation, or simple schedule congestion. It makes the budget discussions more straightforward and grounded in data. Next slide. Slide 14. Major risks and mitigation. When reviewing the risks associated with a telecom upgrade in an overseas embassy setting, the same few issues always come to the forefront: shipping delays, workspace access restrictions, and gaps in local vendor capabilities. Each one has the potential to slow down the job if not closely monitored. Shipping delays are common when equipment must move internationally, and even routine shipments can be held up by customs or carrier backlogs. That risk sits high because switches, fiber reels, and test equipment are all dependencies for downstream work. Research on global supply chains shows that delays in international freight tend to grow the further a project is from major ports, which is typical for government facilities overseas. The mitigation is essential but straightforward. Order early, track shipments in real time, and keep a buffer for long lead items. Access restrictions are another recurring challenge. Embassy spaces operate under controlled entry rules and often require escorts. Those limits can slow installation crews or cut work windows down to a few hours a day. Studies on secure site construction note that constrained access is one of the most consistent schedule risks because crews cannot always move freely. Early coordination with facilities and the security office helps avoid surprises. Finally, many posts cannot rely on local vendors for specialized telecom materials or certified installers. Redundant suppliers, pre-verified equipment lists, and contractor vetting help reduce that exposure. Analysts in international project management point out that supplier redundancy is one of the strongest defenses against material risk. Next slide. Slide 15. Lessons learned. Looking back at the project work, a few lessons stand out that would shape how a similar telecom upgrade should be handled in an overseas embassy setting. The first is how much the design phase affects everything that follows. When design drawings are tight, accurate, and reviewed early, the rest of the schedule falls into place. Research on infrastructure planning reinforces this idea, showing that design quality has one of the most substantial impacts on overall schedule performance because errors discovered later cost far more time to fix. Procurement is another lesson that became clear. For international posts, long lead times and customs delays can easily become the bottleneck. Studies on global project logistics continue to point out that procurement missteps often translate directly into labor downtime and schedule slips. The project confirmed that early ordering, updated lead time tracking, and maintaining backups for critical materials make a significant difference. Crew coordination also proved important. Electricians and telecom technicians may work in the same rooms, but their tasks do not always align without supervision. Research has shown that properly managed multi-trade coordination increases throughput and reduces site congestion. That matched the project experience closely. Finally, preparing for testing early in the project helped avoid delays near the end. Having testers, labeling standards, and documentation templates ready prevented the scramble that usually happens during closeout. Next slide. Slide 16. Conclusion. The overall takeaway from this project is that the embassy's telecommunications upgrade is not just a technical refresh. It directly supports the broader mission by improving reliability, increasing resiliency, and giving staff the communications backbone they need for day-to-day operations. The purpose has always been to replace aging systems with a structured, well-designed platform that meets Department of State requirements and current industry standards. The work across the scope statement, so WBS, and detailed Gantt charts helped create a plan that remains grounded in practical conditions at an overseas post, where access limitations, security windows, and logistics delays are part of the normal operating picture. One of the strongest lessons reinforced throughout this project is how much the design drives everything else. The accuracy and completeness of the drawings affect procurement timing, installation flow, and even the final testing window. In environments with tight access restrictions, design errors ripple across the entire job. The estimates developed earlier in the process showed that even minor missteps in scope interpretation can shift the schedule, especially when multiple trades need to coordinate in rooms not meant for large work crews. Procurement planning is even more important when the project is located overseas. Shipping delays, customs issues, and vendor shortages are common, and the resource plan highlighted the need to order long lead items early and track them closely. When procurement slips, the crew sits idle, labor costs go up, and the critical path feels the impact almost immediately. The earned value approach provides the project sponsor with a simple way to identify these issues early enough to act on them. Another important point is that installation and testing depend heavily on coordination between technical staff. In embassy settings, telecom, electrical, and security teams often overlap in the same areas. When crews share information and carefully sequence their tasks, installation speeds up and testing becomes much cleaner. Final certification is smoother when testers are brought in early for pre-checks instead of waiting until the end of the job. Overall, the project shows how structured planning, accurate estimating, and a practical sequencing strategy reduce avoidable conflicts. Combined with an EVM plan that tracks CPI and milestone progress, the sponsor has complete visibility into both schedule and cost health. The result is a modernized, secure, and dependable telecommunications system that strengthens embassy operations and supports the mission. Next slide. Questions. For those who have questions, please feel free to reach out, and we will get back to you as soon as possible. Thank you.